And I think it's recording. And you can zoom in and out, it's wide angle and all that. If you don't get all of it, I'm going to record it every class today. Would it help if we set it up a little higher?
Yeah.
I got that.
All right.
God, if anybody knocks that off, I'm going to have fits. A little more expensive. Now, see, we don't want to, I'm going to erase all that when I look at the recording.
Okay.
How about if you just set it right there? Does that work?
Let me prop it up with a book.
How about this? How's that?
That's better. Do you want it to see your face?
I don't care. This shows what I'm writing on the board.
Okay, yeah. You're
That's
good
what we
then.
want. It just shows the board. All right, so here's our first example. X minus 1 squared plus y plus 3 squared. And the square has to be outside the parentheses, sorry. And then we're going to put 169 here and 25. And you're going to tell me there's not a square bone, and I'm going to talk to you about that too. All right. When you look at the problem, that's how it looks. Notice the pattern? Okay? Is that cool? Now, what I'm going to do is I'm going to find the center. That's what I always do first. And when you find something, please put it on the graph. When you find something, put it on the graph. Don't wait and have a whole bunch of information because you'll get too much information. All right? So, we're going to find the center. The center is going to be an x value of 1 and a y value of negative 3. Now, don't do graph paper and start counting slashes. Make your graphs big. It's easy if your graph's big. Your graph should be like half a page. Go ahead and make your graph big. If you make your graph too small, you won't be able to see all the information we're going to put on there. All right? Make your graph big. Now, I'm going to cheat this graph, and I'm going to move my x-axis up so that you can see it a little better myself, because I didn't do you a service there, but that low. Okay? I'm going to put the x-axis more like this. Now, I'm waiting for someone to say, well, how'd you get negative 3? Well, if you made that a minus sign, does everybody agree that would be a minus a minus? Mm-hmm. See, if I make that a minus sign there, that would make the k value what? Negative 3. All right. Now, let's talk about the fact that that's not a square under there. Do you know that 169 is what squared? 13. So if I were working this problem, I would take, with a different color pen, I would have written 13 squared there and what? 5 squared there. Now, those numbers are going to help us. Does everybody know that x measures left and right? Okay. Okay. Change in x is right or left. Change in y is what? Up or down. Yeah, that's good. So y'all got it under control there. Now, what you do is see how that 13 is under the x? You count 13 from the center to the right and 13 from the center back to the left. Okay? So, and you don't have to sit up here and count a bunch of slashes. Just guesstimate. 13 is going to be pretty far out there. 1 plus 13 is 14. And notice I changed the x value. I added 13 to the x. Then what am I going to do when I go this way? I'm not going to add it. I'm going to subtract it. And these numbers are important. You've got to put the number values there. Don't just count a bunch of slashes to drive you nuts. You want to put the numbers there. Guess how much I'm about to count up and down? 5, because it's under the y. Yeah, they're under where you're going to use them. So I count up 5. 1, 2. How did I do that? Negative 3 plus what? 5. Okay? -3 plus 5. Then what am I going to do? I'm going to count what? Down 5. -3 what? Minus 5. Thank you, young lady at the front. You know, we might can move it back a little bit if we need to. Is that
That's
pretty clear?
good.
Okay. 1, -8. And I'm going to record every lecture today, and I'm going to use a different example on every lecture, and then we're going to download them all at the end of the day. Okay, notice, and if I didn't draw this very well, it's a lot longer left and right. Is everybody okay with that? If I'd have really been concentrating, it's a lot longer to the left and to the right. How do I know that? Because I counted 13 and what? 13. Here I only counted what? 5 and 5. When you count up and down, you add to the y value, count up, and you do what? Subtract the count down. When you go left and right, you change which one? X. We are ready to draw the ellipse. These are the 4 main points on the ellipse. Now, I'm going to say something I probably shouldn't say on the recording, but if you were going to Loyola, that's all they'd want you to know. Right there. Captain Shreve might want you to know the foci. Okay. Now, I'm going to help us out here. Let's talk about the foci. Okay, so we know how to get the center, and then we know how to count the 4 points, right? All right? Is that cool? I'm going to put get the center, and then count key 4 points, which is pretty easy to do. You just count. Now, the foci. Next thing you want to do is find the foci. The foci are always on the longest axis. Everybody hear that? Foci are always on the what? Longest axis. So that means the foci are going to be somewhere out here and somewhere back here. I'm going to go ahead and put the S there just to let you know that I know they're what? Somewhere out there and what? Somewhere back here. I'm going to tell you how to find out exactly where they are, but I want you to remember they are always on what? The longest. Okay, here's the formula for finding the distance to the foci. Okay, center to foci. There's a formula for it. You take the square root of the big number squared, the big count squared, minus the little count squared. They use the word little guy. Or if somebody says, you mean just 169 minus 25. Yeah, because the big number would be 13 squared, right? And the little number would be what? 5 squared. I write it like this because you've already used the big number to count and the little number to count. Fair enough? Some teachers don't write like that. They just say take the big number that's already squared minus the little number that's already squared. It works. All right? I just like to keep it what? 13 and 5. After you get good at doing ellipses, I'll tell you where that formula came from. If I start telling you where those formulas come from, it's probably going to scare you. Let's get the ellipse done, then look at how the formula was created. So I go over here, and I'm going to go C2 foci equals square root of 13 squared minus 5 squared, square root of 169 minus 25. And y'all probably already knew that I used a triple, right? I mean, you already knew I used a triple there. Yeah, 5, 12, 13 is a triple. We always like it when they're triples. So, I'm going to count over 12. 1 plus 12 is 13. 1 minus 12 is negative 11. And I'm going to leave the little s there. And you'll notice I didn't really put that one in the right place, but it at least gave you an idea of where it was going to be. Now, y'all realize when I count left and right, I do what? Change the x. 1 plus 12, 1 minus 12. You memorize this formula. Ooh, let's use the correct word. You learned this formula, and that tells you how far to count. Okay? Now, after you do that, you found the foci and all that cool stuff. This number out here, the ones on the end like this, where it's turning the most, notice how if you're driving your car, right there is where you have to turn the steering wheel the most. Those are called vertices. Okay? Vertex was the word you learned for parabolas because vertex is singular, but these are the vertices. Now, these are the vertices. Okay, those are called the vertices. So we found the foci, we found the vertices, and really, when you found the 4 key points, you knew one of them was a what? You found the vertices right there. When you found the 4 key points, you actually found the vertices. All right? Now, let's talk about this. Let's do this. Major axis is always the longest line that divides it. Major, think about the word. Major, it would be the what? Longest line. Okay? It's the longest. Then we're going to find the minor axis. Guess what? The minor axis is the shortest. So in this case, the major axis is y equals -3. Major. Y equals -3. Because y'all know that horizontal lines are y equals and vertical lines are x equals. How many of you remember that? Everybody remembers that? Yeah. Horizontal lines are y equals. Now, let's go ahead and talk about the minor axis. I bet you can guess which one the minor is. The minor is the one that is the short one. X equals 1. Okay? All right. Now we're going to do the 2 bits of information that really set you apart. We're about to do the college part of this problem. Okay, we're going to do the college part. We're going to talk about something called the latus recti. Latus recti. Okay? And what the latus recti are, I'm going to go over here and I'm going to put a dot where the latus recti go. The latus recti tell you how wide it is at the foci. Notice how they line up with the focus? They tell you how wide it is at the foci. Latus recti. How wide is it at foci? I'm going at a decent pace here, not too slow that you get bored, not too fast that you have a question. Okay? Does anybody have a question about anything up to this point? And then I'll do them. Okay, I'm going to tell you the formula to find latus recti. It is the little number that you did squared over the big number. And that's the distance from the focus, foci, to latus recti. I just put an LR there. But the focus distance to the latus recti distance is the little number count squared over the what? Big number. So it makes it easy because if you go over here, I'm going to do it right up here. I'm going to do it in that same color blue that I wrote that in so that you'll see it. Okay, focus to latus recti. You take the little number 5 squared over 13. So that's what? 25 over 13. And yeah, you got to do fractions, folks. We do not do decimals in here. We do what? Fractions. So, this is going to be 13, comma, negative 3 plus that. Now, just to help you out here, I'm just going to write that. 25 over what? 13. And then what would you do in the next step? Get a common denominator and put them together, right? Get a common denominator. So that's going to be 13, comma, 39, 14, negative 14 thirds. Don't write 14 thirteenths. Please do not write mixed numbers. Leave them what? In product. Okay? Now, put those together. Now, what's going to happen? If I added the 25 thirteenths to go up there, what am I going to do to go down here? I'm going to what? Subtract it. And when I subtract it, I'm going to get negative, let me go ahead and write that, negative 3 minus 25 thirteenths. Because y'all can do y'all can do a little addition and subtraction. 13, comma, negative 64 over 13. Okay? Now, don't forget that you found 2 over there, but there's also what? 2 back here. What's going to be true about the y values? What's going to be true about the y value here and the y value here? They're going to be equal, right? Mm-hmm. Yeah, because what? Negative 3 count up, negative 3 count what? Down. Negative 3 count up, negative 3 count down. What's the only thing different about these is the what? X values. So it's going to be negative 11, comma, negative 14 thirteenths, and negative 11, comma, negative 64 thirteenths. And those, folks, are your 4 lattice recti. Now, remember when I told you in this class you'll have to learn lots of details. Yes, you have to put all of that on there. All of it. Somebody says, well, when will we ever use lattice recti? Well, if you're in college in physics, you'll use lattice recti. Okay? Somebody says, well, when would you ever use vertices? You'll use those in like a lot of things, because that's where it turns the most. That's where you get the greatest change in direction. Anytime you're looking for vertices, always imagine driving your car around this and think, where would I have to turn the steering wheel the most? Greatest change in direction, vertices. Now, there's one thing left to find. It's called eccentricity. It's a biggie. Eccentricity. No, it's S. Mr. Travis, y'all are going to appreciate this because I want to show you something about this one. This one is one of the ones that you don't use until you're like really way down the road in mathematics. Okay, this is something you see at the Calc 3 part of the book. They start talking about this. But if you look, you will notice that Mr. Evans must have had problems in remembering the formula. Because to find, I don't know how to do that, eccentricity, there's the formula. Okay? I may have to look this up in a book and remember how to even spell it. Okay. ECC. I hope this is right because, they're recording this for all the students at home, and some parent is going, I can't believe he spelled that wrong, because that's not how it's spelled. And Mr. Travis is back here looking for the book so he can see how to spell it. I don't think it's in the college algebra book. I think it's only in the calculus book, but let's see. ECC. Ellipses. Center equation foci is not in the college algebra book. I bet. Yes, sir.
I found how you spell it.
Oh, you looked up on the internet. See, I'm a smart kid. Am I close?
Yeah, you got it.
Oh, I got it?
You got it.
Oh, man. Now, how you pronounce that, you got to remember, I failed phonics multiple times, so it's probably eccentricity. Eccentricity. You look it up, go to one of those things. But here's what's really cool about it. It's easy to work. It's the distance center to focus over the distance center to vertex. Okay? So it's one of those things that's really easy to do if you have the formula. Now, am I going to provide the formula on the test? No. So when you look at this, you have to know how to find the center, the 4 key points. You've got to have the formula for the focus, distance, major axis, minor axis, latus, recti, and the eccentricity. You memorize the formulas, and you're thinking, oh, I can't believe he moved that after I had it set up perfect.
Okay.
Now, eccentricity is pretty easy. How far was it from the center to the focus? 12, right? So E will equal 12 over, and the center to the vertex was only what? Center to the vertex was 13. Center to focus over center to vertex. And that's true for ellipses and hyperbolas. All right? And ellipses and hyperbolas. It's true for both of those. Okay? So that's the formula. And I always forget it because you never use it unless you're going into like heavy-duty physics or heavy-duty math courses. It's, like I said, it's not in the college algebra book. Fair enough? All right? That's everything that we find when we do an ellipse. That's the whole story. Would you like to do one more? Okay? We'll do one more. I'm going to make up another one. And the hardest thing a lot of students say is finding the fractions because they didn't force y'all to learn how to add and subtract fractions. They let y'all use those calculators. Throw your calculator away. You do not use calculators in here. Throw them away. Oh, and if somebody says, well, Mr. Evans, you know you can graph an ellipse on your calculator. Your calculator won't tell you the eccentricity, it won't tell you the latus recti, and it won't tell you the focus. Okay? Or the foci. So, and it's not easy to graph on it because your calculator is designed to graph functions. These graphs are not functions. Y'all remember the test for functions? If you draw a vertical line, it only touches it once. Notice if you draw a vertical line here, it's going to touch it how many times? Twice. These are not functions. Okay, here we go. Oh, and there has to be a plus sign between them. Later on, that'll matter because when we start doing other shapes, there'll be a minus sign there. But for ellipses right now, there will always be a plus sign. But just so you'll know later down the road. All right. X plus 2 squared plus y minus 3 squared. They'll always equal 1 for right now. When they don't equal 1, I'm going to show you what to do. But for right now, in order to graph them, they have to equal 1. All right. Notice I put the big number on this one under the y, just to make it look good. All right. Can everyone tell me the center? What's the center value? Yes, ma'am. Negative 2, 3. And you said it loud enough I could hear you. Very good. Okay. Negative 2, 3. And remember, I've already told you, draw these big. -2, 3. And honestly, the number values is what's important. Because you're going to be using the numbers to do something with them in other courses. All right? -2, 3. How much am I going to count in the x directions? Not 9, just what? 3. Because remember, you always want to take that number and make it 3 squared and make this one what?
4 squared.
4 squared. So we're going to count 3 in the x directions. And I'm going to exaggerate this a little bit. -2 plus 3 is 1. -2 minus 3 is -5. Please remember, when you move left and right, what number do you change? You change the x. When you move left and right, you change what? X. How much are you going to count up and down? 4. So it's going to be longer what? Up and down. -2, 7. And -2. Mr. Evans, you didn't even get close on making that graph up. And you see why Mr. Evans never always really that well prepared in the first class. There we go. Yeah, I didn't do a very good job of counting there and making it okay, let's draw the ellipse. Now, got a question for you. Anyone need to talk to me about these 4 or these 5 points? Because if you get these 5 wrong, everything's going to be wrong. You get the center wrong. Oh, man. Okay. Are the foci going to be up here and down here, or left and right? Where are the foci going to be? Yeah, they're going to be up. They're going to be up and what? Down. I go over here and I find the foci distance. And I go square root, this is C2F equals 4 squared minus what? 3 squared. And I get square root of 7. Don't panic, all right? We'll show you how to handle that. This is easier than if it was a fraction. Y'all know that square root of 7 is a little bit bigger than 2 and a little bit smaller than 3, right? We'll go up a little bit more than 2, right here, and make this point -2, 3 plus the square root of 7. It's that easy. And what are you going to do about the one that's down here?
Excuse me.
How you doing?
Instead of last name Gamble.
Gamble? Yes, ma'am. All right. Okay? You're going to count down the square root of 7. So you're just going to write what? -2, what? 3 minus square root of 7.